So the first continuous distribution we're going to look at here is the uniform distribution. So this is the distribution where the probability of every value is the same. So we've got some values here on the x-axis. We'll call them a and b. And then our f of x, remember, is our relative frequency, probability of x. And then the area underneath the probability distribution here is always equal to 1 or 100%. And so the base of this rectangle is b minus a. And that means that the height of this rectangle is going to be 1 over b minus a. That way when we multiply base times height, we get that area of 1. So some notes about this distribution here is that x has values only inside that interval from a to b. So outside that interval, the probability of x is 0, so no values outside the interval. Our probability function here is equal to a constant, 1 over b minus a. So a and b are constant, so 1 over b minus a is a constant fraction. And then that area, in order for that to be 1, we need to have base times height of that rectangle, which is b minus a times 1 over b minus a is equal to 1. So this is called the uniform random variable. So that probability distribution f of x, which is our p of x, is 1 over b minus a for x between a and b. Our mean here should be in the middle of the distribution, and that's going to be right here, and that's going to be the average of a and b. So mu is going to be a plus b divided by 2. And then our standard deviation sigma is b minus a over root 12. And this is derived from an approximation here of taking the range here, b minus a, and divide by 4. Or more generally here, this would be the range divided by 4. So that's based on an approximation of range divided by 4. So 2 standard deviations below to 2 standard deviations above in a normal distribution or bell-shaped distribution contains about 95% of the data. So that's what this standard deviation is approximately based on. So let's look at an example using this uniform distribution. So we're going to take uniform distribution with a equals 2 and b equals 6. We want to find mean and standard deviation, probability that x is between 3 and 5, and then the probability that x is within 1 standard deviation. So let's go ahead and sketch this distribution. So there's our vertical p of x and our horizontal x. And then we're going from 2 to 6. So we are going to have a rectangle here. This is 4, so the height of our rectangle is going to be 1/4 because the base is 4. So this is not quite drawn to scale here, but this is going to be 1/4, and then this will be 4. And then our mean right here is going to be 4, right in the middle. So our mean is 2 plus 6 divided by 2. 8 divided by 2 is 4. And then our standard deviation, b minus a over root 12. So that is going to be 6 minus 2 divided by square root of 12. And let's go ahead and compute that on the calculator. So 6 minus 2 is 4. Divide by a square root of 12, 1.155 approximately. And then probability that x is between 3 and 5. that is going to be this area right here. That's probability that x is between 3 and 5 with distributions here, continuous distributions. Probability corresponds to area. So that's a rectangle with base 2 and height 1/4. So this is just 2 times 1/4, which is 1/2 or 50%. 0.5. Probability that we're within one standard deviation, well, we need to figure those cutoffs here. So our mean is 4, and we subtract off 1.155, and that's going to be less than x is less than that mean of 4 plus 1.155. So that's just asking what is the probability that x is between, if you subtract 4 minus 1.155 here, you will get 2.845. Got kind of a deformed 8 there. Poor guy. Didn't get much sleep last night. There we go. Less than x, less than, this will be 5.155. And then the area, again, this marks off a rectangle. 2.8 would be about right here, and then 5.1 about right there. So the base is going to be the difference between those. Height's still 1/4. So the base of our rectangle, 5.155 minus 2.845, and then the height, 0.25, 1/4. Go ahead and compute that. So 5.155 minus 2.845, 2.31 times 0.25, 0.577, so approximately 0.58. Oh, we can go ahead and keep our decimals here. So 5775. So probability is area. So again, this is area, and this is area.